95. This video is going to be for the chapter 8 notes. They're on polynomials. They're not super long, this chapter. They're about 4 pages. And I think some of this you'll kind of remember from other classes, probably. If you don't, that's okay. But I don't think it'll be anything too new for you. So in chapter 7, we talked about exponents. We'll kind of be using some of those exponent rules a little bit in chapter 8. And then we're working toward factoring in chapter 9. If you don't remember what factoring is, that's perfectly fine. Okay, so we're talking about polynomials. Okay, just to kind of refresh our memory, a polynomial poly means many, has many parts, and it could look something like this. This is an example of a polynomial. Okay, so it's made up of parts that are separated by addition or subtraction. Each of these is what we call a term. So a term can be just a number, it could be just a variable, just an x or a y, or it can be a product of those. Like 3x is a product of a multiplication, right, of a number and a variable. If we have 3 terms like this, it's called a trinomial. If we have 2 terms, it's called a binomial. If we have a polynomial with just 1 term, it's called a monomial. If there's more than 4 terms, there's no special name for it. It's just a polynomial with 4 terms or a polynomial with 8 terms. And these are also all polynomials, they just have a more specific name. So I always say it's kind of like if you have a poodle. You have a poodle, but it's also a dog, right? So you could just say those are a bunch of dogs, or you could say that's a poodle, and that's a German Shepherd, and whatever. It's kind of like with these. Okay, so again, terms are separated by addition or subtraction signs. And this sign goes with that term. So we think of this as -4, and you'll see as we're combining them. So what we're going to be doing in this chapter is we're going to be talking about adding and subtracting polynomials, multiplying polynomials, and dividing. So when we are adding or subtracting, and I'm going to assume that you have the notes in front of you, or you can at least look at them online, so I'm not going to write every word up here. But you see under adding and subtracting that we can add or subtract like terms. And we talked about this back in chapter 2, I think, 2. About adding and subtracting like terms. Like terms have to have the same variable and also the same power. So x squared can get combined with x squared, but x cannot be combined with x squared because they're the same variable but different powers. The exponents don't change, and when we have subtraction, we'll have to kind of make sure that the subtraction gets distributed throughout the whole polynomial. So if I have, for example, 1, this reminds us probably of things we did back in chapter 2, where we're looking for like terms. So I have here 5x to the 3rd plus 2x plus x to the 4th minus 3x cubed plus 5x squared minus 7x plus 2. Okay, now here I just have a bunch of different terms, right, that we're adding and subtracting. You may also see something where, let's say I have things like this in parentheses. Maybe here's one polynomial and I'm adding it to another polynomial. If I'm adding, it doesn't matter if there are parentheses there or not. If I'm just adding, it doesn't change anything. So we're going to be looking for like terms. So let's say we start with 5x cubed. Then I'm looking for something else x cubed. I'm going to see that I have -3x cubed. So I'm thinking about, just like we did before, I'm thinking about combining like terms based on what their coefficient is, what that number in front of the x cubed is. So 5 minus 3 gives us 2, so I have 2x cubed. Then next I have 2x, so I need to look for something else that has an x. I have 2x minus 7x is going to be minus 5x. Here I have an x to the 4th power. I don't have any other x to the 4th, so there's nothing else to add to it, so I just have that x to the 4th. Here I have a 5x squared. There's no other x squared term. And finally, I have a plus 2. So I've combined all my like terms here. I still have 5 terms in my answer because a lot of those didn't combine with anything else. And then what I want to do finally is to put it in what we call standard form. So standard form for a polynomial means that my exponents are from highest to lowest. So I look at my terms and I see that I have an x to the 4th, and then I'm going to have an x to the 3rd term. Now this one is positive, I can tell because there's no negative in front of it, so it's going to be plus 2x to the 3rd. So when we move things around, the sign in front of it goes with it. So plus 5x squared. And then minus 5x plus 2. Okay, so when I moved this 5x, this negative 5x, the negative sign went with it, no matter where it ended up in the polynomial. All right, the next one is labeled example 3, but you can tell it should be example 2. Sorry about that. So I have x to the 5th minus 6 plus 2x to the 4th minus x to the 4th plus 5x squared minus 7x squared plus 2. All right, so let's just go ahead. Why don't you take a minute and look for like terms and think about combining like terms. Stop the video for a second, try it on your own, and then when you come back, we will go over it. Okay, so when we look at this, we have x to the 5th. There's no other x to the 5th, so nothing else for that to combine with. I have 2 terms that have x to the 4th, so 2 minus 1 is 1. X squared, 5x squared minus 7x squared is negative 2x squared. Notice there was no x to the 3rd, and that's okay. There are these two. And then this is a plain old, there's no x either. There's a plain old number, a constant, we call that, because it doesn't change. Negative 6 plus 2 is going to give us negative 4. So we get to this point, just don't be tempted to start putting more things together. We can't because they're not like terms. And so same with this. It's a long answer because none of those are like terms and they cannot be combined. When we look at this, this one's already in standard form. X to the 5th, x to the 4th, x to the 2nd, and then no variable. Really, if you think about that last term, if we think about what we know from last chapter, x to the 0 is like 1, right? So it's as if it has an x to the 0 there, which would just be 1. 4 times 1 is 4. So that does still go in order of decreasing those exponents. All right, so if you look on your notes at number 3 and 4, those both now have subtraction. And as usual, right, having a subtraction or a negative kind of makes things a little bit trickier most of the time. So let's just, before we get to number 3, let me just do another example up here that's just much simpler, okay? So let's say I had 2x plus 5 minus 3x minus 4. So what we can't do is just take out the parentheses. If it were a plus, we can take out the parentheses with no problem. If it's subtraction, we cannot do this, okay? I'm going to put no here. And let's see why. Well, here I have 2x minus 3x. I still here have 2x minus 3x. That first term is going to be fine. It's the rest of them after the subtraction that are not going to be right. So really here I have 5 minus negative 4. So I have 5 minus negative 4. When I come down here, if I've just pulled the parentheses off, I just have 5 minus 4, not 5 minus negative 4. Because there's nothing here saying that all of this had to be subtracted, right? That parentheses is saying I'm subtracting this and I'm subtracting this. So we cannot just pull off the parentheses. What we can do, if you want to, is I can rewrite it with no parentheses, but this sign basically gets distributed through everything in there. Think about it, if I multiply by just a negative 1 is what I have there, The numbers are all going to stay the same, but the signs are going to change. So if I have minus 3x or negative 1 times 3x, either way, I'm going to have minus 3x. Minus a negative 4 or negative 1 times a negative 4 is going to be plus 4. Then I've taken into account here that I had to work through that subtraction to get to this, and then I would be okay. Or if you're very comfortable with negatives and subtraction, you can leave it with the parentheses if you want. So let's look at example 3, the real example 3. So I have 13x cubed minus 9x squared minus 7x plus 1 minus negative 7x cubed plus 2x squared minus 5x plus 9. Okay, so again, if you want to rewrite this without any parentheses, we can. One way sometimes people think of it as kind of a shortcut is to change this to a plus and change everything here to its opposites, which is what's happening, right? You can also think of it that I'm saying minus a negative is plus, but minus a positive is negative. Or you can think of this as negative 1 times all of that, okay? So let's rewrite it here without parentheses. So the first part is exactly the same. It's just whatever's after the parentheses that changes. Let me see if this marker is any better. Yeah. All right. Maybe a little bit. My markers are dying here. So that first part is all going to be the same. Now, minus negative 7 is plus 7x to the third. Minus 2x is just going to be minus 2x squared, right? Or you can think negative 1 times a 2 is negative 2. Minus negative 5 is plus 5. So plus 5x minus 9, it's like that. Okay, now I've taken away the parentheses, but I've also taken into account the fact that this subtraction has to go all the way through there. I've changed these to reflect the fact that I'm not adding 2x, I'm subtracting 2x squared. So now let's look for like terms. So 13x cubed plus 7x cubed is going to be 20x cubed. Negative 9x squared minus 2x squared is negative 11x squared. Okay, now a couple of things I want to point out before we go any further. Notice that my exponents are not changing. And we talked about this back in chapter 2 about when we combine like terms, the exponents don't change. And it says that on your paper too. But we've got in that exponent rule idea. That's when we multiply. We'll do that in a minute. But when we're adding and subtracting, they do not change. Okay, think of them as a thing. I give you 13x cubes, whatever that is, and I give you 7 more. You still have x cubed. You just have 20 of them. Okay, so now we go to the negative 7x plus 5x is minus 2x. And then plus 1 minus 9 is minus 8. Again, don't get tempted to start combining those. They're not like terms. Okay, this is what that last bullet up on top means. Make sure the subtraction gets distributed through the entire polynomial. All right, so the next one has subtraction and addition in it. So we have 9y squared minus 11y plus 12 minus 4y squared minus 5y minus 5 plus 11y minus 14. Now, when I distribute this negative through, it only has to go through this part, right? This part is not being subtracted. These parentheses are kind of like a fence. So this goes all the way till this end of this parentheses, but not any further. All right, so what I want you to do is I want you to go ahead and try this one. Okay, if you want to rewrite it, this will be the same as it is, and this will be the same as it is, and this will have that subtraction distributed through there. And then you're going to look for like terms. So I'm going to stop this video. The beginning of the next one will pick up with the answer to this, okay? But go ahead and try it before you start the next one.